Skibbity Rizzler 6-7, my guys. Bet. Cool. No cap. Today's lesson will slap. All right, check it out. Hey, I already had this set up. If I do this on my page, and I didn't even check the volume levels. All right, so as we're looking at this thing, what I see is a 90-degree. Now, I don't have the graph in front of me. You guys did it all with the graphs and physical pages, right? So as we're here, based on the rule that you have seen, I think it's reasonable to expect that you could help me work out my rule here. Yeah. So this is all scratch paper currently, and for some reason there it goes. Sweet. Okay, so if I want to get to A prime, what happens?
Of the X and the Y.
So you claim that these swap, is that it? It's just the point 1, 3?
Yeah.
No.
And also whatever goes in the X axis,
So, and this is a weird way to word it, but I think that I agree with you. Whatever was here, or whatever was Y, or is now X, and this is why it's so gross. I'm going to phrase this, the number that's in front, after the rotation, which is this, whether we call it X or Y, it changes sign, I think. So I believe that my first point was -1, 3. Okay, now for 180 degrees, if we started at A, and I'm going to call each of these A prime, just for the record. Okay, using your rule that you discovered, whether it was the 0.31 or not, what happens with these points? They swap places, so they do swap again. So here's 1, 3, but something else changed. They both changed signs, didn't they? So, for example, somebody who used a different starting point, what was your initial point?
Well, it's more like after, because like.
And you're seeing composition without saying it, is what you're seeing. I agree with you. Give me any other point other than 3-1 to start. Did you use 6-7?
No, I used 3-1.
Okay, did anybody not use 3-1?
I used 4-1.
If you use 4-1, you're 180 degrees. It better be -1, -4.
Yeah.
Cool.
Got that. So I used 3-1, but I got -3, -1. Wait, I got -3.
Oh, did I just write it? I just wrote it backwards. I tried. I even drew the
Oh, yeah,
swap.
it's -3, -.
Yeah, I don't know what I did. I'm sorry. -3, -1. How come you didn't like? You were waiting to not interrupt me, which I appreciate. Anybody else notice I wrote down the wrong point? Why did you not say something right away?
Because I thought maybe I was wrong and you were right.
Okay, reasonable thought, but I wouldn't trust that. I wouldn't trust that. Okay, are we okay here?
Yeah.
All right. So if we look at this, I'm okay with that. Looks like A prime. If we go 270 degrees, I think it's going to be 1, -3.
Yes.
Okay, or I'm trying to think. Yours would be 1, -4. Liam, 270 is 1, -4.
270.
Is yours 1, -4?
Yeah.
Okay, and 360, it almost feels silly to write out. If you spin a full circle, where do you end up? Same spot, so it'd be 3-1 in this case. Now, it is nice to do it this way. Historically, what I've done is use a protractor, and I made people measure the distances, and it's blah. Okay, from this, if we wanted a general rule, could we make that happen?
Yeah.
So, there's a few ways that we can organize this, and I'm going to leave it entirely up to you guys. And it's, I can't decide if I love sitting here or hate it, because it's super weird when you guys can't see me.
I assume I can hit you in the back and I look over here. It's, I don't know.
Okay, well, I'm going to try to stay moving, because the goal is to not just sit, and here I am. But check it out. What I want us to do, we need to make a decision. This is all of our scratch work, and if it's on that scratch paper, I'm fine with that. Back in our notes, we want a general rule. So, if this is all scratch, I'm going to go back to my notes now, and we're going to just go ahead and say, here's the example that we did. We rotated it. Let's work about a generalized rule. So, generalized rule. And this is going to be wordy. I would encourage you to try to shorthand it. We're looking for a generalized rule when rotating around what point? When rotating about the origin. And it is weird to hear it, and it's even weird when you think about it to make sense like grammatically, but when we talk about the point we're rotating about is the origin, we do use the word about. And I don't know why it feels kind of unnatural to me, but we are going about the origin. Now, there are, of course, other points that we could pick, or other angles that we could pick. I'll tell you, we picked all the really nice angles yesterday, we won't get to see how nice they are in this class for a while. We use 90, 180, 270, and 360. When we're looking at these, we want a generalized rule, and we're just going to write it as follows. If you give me any point, A, and instead of using X and Y, because that kind of makes it weird to talk about what's where, I'm going to use A comma B. Is that still just an ordered pair? For sure. Now, we're going to look at A, and it's represented as A comma B, and I need your guys' help with this. When we look at this, there's two ways that we can present this idea. We can do each of the 4 rotations. So I can say a rotation by 90 degrees. And then I can do another one with rotation of 180 and 270. Now, Ronaldo recognized something, and I don't want him to say it yet, but there is a way to generalize this rule, even more so than doing 180 and 270 and 90. What happens with these points? So they switch places, A comma B, sorry, B comma A, and we switch the sign on the new front number. If you look at the points that you used, does everybody agree that this is exactly what's happening? Okay, now, Ronaldo noticed something, and we're going to use it. We might even write all 4 of them still, because it's nice to have a shortcut if you need it. But if I wanted to rotate 180 degrees, do I have to do it in one smooth motion here? Could I break that into 2 smaller pieces? What would those 2 smaller pieces be? If I wanted to get there, does everybody agree I could just rotate 90 and then do 90 again? Like, I'm composing, right? I'm doing the reflection above 90 degree, or the rotation by 90 composed with another rotation by 90. With that in mind, it is entirely up to you if you want to put these ones. But if we go from AB initially, and we wanted to instead rotate 180 degrees, as long as we have this first rule, we don't really truly need to do any more graphing at this point in time. Because if I wanted to rotate 180, it's just like doing this to get here, and then could I go another 90? And what's the rule for 90? They swap, and then the front one does what? So I agree with you, that's what it's gonna look like. I'm just gonna say change sign, and I know that that's what negative means, but if it's a negative number, I don't want us to keep it negative. So, check it out. If we swap these around, it becomes A comma negative B. Do you guys agree with that? If I swap the already 90. But what happens to that first sign?
Stays negative.
So here's where it is, and now it becomes negative. Or it becomes the opposite sign. Now, you can verify this on your page, but we don't need to really do all of them as long as we know it's just some additional rotation by 90 more degrees. Same thing. If I want 270, could I do 2 steps where the first step is 180 and then the next step is 90? And if we did that, A, B is where we're truly starting, but I'm trying to think about it as compositions of many of them. And we rotated 270 degrees. I could simply look at this and take this point and do the same thing again, right? Swap places, becomes negative B, negative A. And then what do I do with the negative here? It changes sign. So instead of negative B, what are we going to write? B, A, or B comma negative A. Now, the last one, I'm not even going to bother to write because it does land exactly on itself, but we can verify that. If we switch these and change the sign of the front one, we would get A comma B. If I start at AB and then go a full circle, do I end at A? And I see it works. Whether you want to have 3 rules written out so that you can easily and quickly reference them, or you want to use the fact that you can do 90 degrees multiple times, is entirely up to you. Most people, and when I thought this before, I didn't give that option. Most people just used these rules, like all 3 of them, and they had it on their note card, whatever. You don't really truly need them. Okay, this generalization feels okay, feels awful. Have I lost anybody with how we were able to reason this out? Okay, so with that said, I'm going to look a little bit and we're just going to make some general notes, and I'm only going to use the picture that I had. So you guys can keep drawing on your picture if you want, but I only need a couple points and I'm only going to put 2 of them. A prime, I lied, I'll put them all. What was a double prime for us? 180, -3, -1, okay. Okay, I'm going to put this graph back up. I only have 90 and 180, but you guys all have similar pictures Did you do it on one graph or a bunch of different graphs? Okay. What I want you to do is take 10 seconds, put all 4 of your A prime points on a single graph.
We did 4 points. We had to do all 4.
You should have all 4. And if you didn't do all 4, you can get your last point using that new rule that we just worked out. I'm sorry? Because on each of them, I counted this rotation by 90 as a single operation, and then I counted the entire operation here. Like, you could use double prime instead. I'm fine with that. Sevilla asked a fantastic question. Why did I use A prime every time? And that, like, it's a good question. The only reason is because here, our first step was a single rotation, and it went from pre-image to image. That's that A prime. And then I'm pretending like that one didn't happen, and I'm going from 3-1, a whole rotation of 180, and it would be at A prime again. If you want to call it double prime or triple prime, you're good. It's just a notation difference. Okay, a couple things that we want to notice about these points. Now, eventually we'll be doing like triangles or whatever it is. Doesn't really matter what the point necessarily is, but every single point will have some pretty nice common characteristics that we can deal with. So the first thing that I kind of want to draw your attention to is, do you agree that I need to go 1 horizontal and 3 up to get from the origin to here? Okay, so this real distance, it's not nice, it's root 10. And I just did the Pythagorean theorem, 1 squared plus 3 squared. If you have a different number, you might get a nicer number, but that's a distance of root 10. The square root of 1 squared is 1, plus 3 squared is 9, and 1 plus 9 is 10. This is the Pythagorean theorem. Okay, now you don't really need the triangle. I assure you it's root 10. What is the distance from the point that we rotated about to point A, do you think? Root 10. What do you think this distance is? And the last one? So if we want to generalize that observation, it is still root 10. We're just going to make a few little brief observations, and we'll call it note. I'm sorry? You're still going to get the same thing. The distance will be preserved. You won't have root 10, but you'll have the same distance. And if you're not sure, I can come check with you. So I'm just going to note a couple little things about these. When we do these transformations, we get a bunch of stuff that works out really nicely. So one of these is that the distance, we'll just go ahead, distance from, and I'm going to introduce a new language here. It's still English, but some new words. The distance from the center of rotation, which, what do you think, and we haven't defined this yet, what do you think our center of rotation was just now? It was the origin. It's the point that we're rotating about. The distance from the center of rotation to A or A prime. It doesn't matter whether we go to A or A prime if we're going by any angle, but it's, here we only did these 4. Those distances on all of them were the what? The same. You can say equal, congruent. I'm going to say equal since we're talking distance. We always preserve the distance from where we rotated about. Now, one more little thing. Did we, and I don't want to word this one, I'm not even going to bother that one. If we had a triangle, and we will have a triangle, we'll see that it's the exact same triangle. It doesn't reflect. It's still the same direction, even though it might go from pointing up to down. It's still A to B to C and A to B to C. Like, it works. Okay, this is really the big observation I wanted to make. Okay, on the coordinate plane, super hard. I'm really debating if I want us to do this if it's not on the coordinate plane or not. We'll see. Let me think about this. I'm going to give you guys a quick practice problem. Now, if you have any empty graphs, you are not required to graph these, but if you're not sure about your answer, would the graph tell you whether or not it looks believably to be correct? I think so, but based on the lack of really clear what I'm asking, I'm going to say for the following, graph the pre-image and the image when you were done. Cool. If you need more paper, I got you. Let's go ahead and make a triangle. So we're going to take triangle ABC, and we're going to rotate how many degrees? Okay. Check this out, though. We're going to say 90 degrees clockwise. We'll address this together. That's it. here's what I want. I'm going to pick out some nice or terrible points. I haven't decided. Henning, where's the first point? Where's point A, not the origin? 2, 4 is point A. Awesome. Point B, where, Michelle? 8 and 7. Let's make it negative 8 and 7. I'm cool with that, though. And C for Akis. Doesn't really work, but give me a point C. Any point, not the origin. 4, 1. I'm cool with that. Okay, before I just cut you guys loose to do this and check and verify that we can knock these out, there's something weird about my directions. 2 things, but you probably only noticed 1. It's clockwise. Are we supposed to turn clockwise? You can, but we don't have a rule for it anyway, because all of our generalizations just now, or we do, and we're just going to make sense of it. Check it out. I'm going to start just straight over. Here's 0 for you guys, right? Okay. If I go clockwise, I'm going to do it from here. If I go clockwise, 90 degrees, I wind up here. Everybody agree with that? Okay. If I went clockwise, is that clockwise for you guys? Oh, man. If I go clockwise, I'll end up down here. Okay, so I'm not going to keep my arm here because it's not going to work. But imagine it's still here. If I go counterclockwise, the regular direction, is there an amount of rotation that ends me in the same spot? So we're not really going to write it's a rotation by 90 degrees. We're going to write it's a rotation by 270. It's the same angle. We want to make sure we're working clockwise. So here we go. I'm going to put the 270 degrees. If you use capital R and with a 270, that's what your book uses. Be very careful. Lowercase r in your book means reflection. Capital R means rotation. And we'll summarize this as well. If you don't want to have to deal with that, I simply do it like this. Okay. Now, the other thing, I think you all would make this assumption, but I do need to be clear about it. Which points did I tell you to rotate about? So these are the points that are rotating. But where's my pencil doing on paper? Did I tell you? Okay, where should we make it? I'm okay with the origin for the first one. Say clockwise, and we'll just make that a comma. I know it's not grammatically correct, but we'll say about 0, 0. Okay, I want you guys to rotate each of these points 270 degrees. When you're done, you're going to graph the original triangle, the pre-image, and the now rotated triangle, the image, on your page. Hook it up. I think that this becomes what? 4, negative 2? And this becomes B prime. I bet it's going to be 7, 8. And C prime will be 1, negative 4. So, no. Well, possibly. But let me before I just say no. Rather than learning 6 rules total, I'd rather, instead of trying to work out a rule for the clockwise rotations, because they're so rare, everything we do is counterclockwise, and we'll talk about what a negative angle is eventually. Turns out it's this. It is better off and easier if we all just agree, let's just change it to counterclockwise and work with the rules that we have. Otherwise, we need double of everything. There is a shortcut. If you want to use a shortcut, I'm not going to use it. You're welcome to, but I would encourage stick with the convention. Okay. All right. One more. This time, you do not have to graph it. But I'm going to give you you can if you want to, and it might help because this is going to be a little bit harder of a problem. Okay. This time, we're only going to do a segment, which is a little easier to do. But here we go. We're going to do the following. I want AB to rotate, we'll say, I don't know, 90 degrees this time. I'm fine with that. About 2, negative 1. Now, I am very well aware that we have not done a problem like this. I promise and I assure you that you have seen every single part that's needed to solve this problem. There's nothing new happening except we haven't demonstrated it yet. You have all the tools necessary. I want to see if you can put it together with all the tools available. We'll all come around. I'll check back in. We will certainly talk about this, but I want you guys to try it and see if we can maybe work this out. Cool. We are doing it without a graph. If you want to use a graph to help you, that's fine with the first point. Oh, you probably need AB, huh? All right. I can probably hook you up. A is the point, and I'm going to challenge. I want you first to try to do it without a graph, using only what you know about 2.1, 2.2, or 2.3. Let's say A is at the point -3, 4. And B lives at the point 6, 4. Teen. There we go. Yeah, I changed it so that it wouldn't just be a horizontal line. It is 14. I did not intentionally mislead you. I just didn't want it to be a horizontal line. I'll rewrite it. 14. This problem is significantly harder because it's 2, -1. Okay. Now, I'm going to use this graph paper just because I happen to have it. And you guys might be just using your sheet here to try to get it. But I think if we generalize out a rule for this, and it's not so much as generalize a rule, but an approach, we can make the problem easy. Do you guys agree that if there's a hard problem, if you can make sense of it like an easier problem, it gets easier? Like always, there's a reason we start with easy problems first. So check it out. I have the point -3, 4. So we're going to go by 2's, right? -3, 4 lives right here. That's A. I'll put it up there. Yep, I got you. And B is at 6, 14. 2, 4, 6, 8, 10, 12, 14, and 2, 4, 6. Okay. I had to go outside of where we were working. If you drew it, do y'all have a similar segment? And not a lot of feedback there. Even if you didn't draw it, we might have picked a different scale. Do you guys agree that I've plotted the 2 points? And we're rotating about which point? 2, -1. Well, that sucks. That's what makes it hard, right? What do you want, or what does everybody probably wish the point we're rotating about was? Well, gosh dang it. It's not the origin. Can we just move everything? So, for example, if you didn't catch what I just said because you were chatting or just missed it, we want this point. It'd be nice if it were 2 to the left and 1 up. Everybody agree it'd be real nice to move this point right here. And we just said that was, gosh, if you just physically move a point, what's it called? And how would I say translate 2 left and 1 up? -2? I need to go left 2, don't I? So I'm trying to go from, so you're both correct, and I don't think you realize that you're saying the same thing. This is the point 2, -1. To get to the origin, I have to move 2 left and 1 up. So if I'm trying to make -2, or sorry, 2, -1 move to 0, 0, I subtract 2 and I add 1. If I do that to this point, what other point should I do it to? Let's do it to the other point. Now, when we do this, it means that we're going to add an extra step in here, and might be more than one extra step. Adeline, go ahead.
I did like the transitions thing, and then I did 2, -1, and if I combined, like I added them on.
Let me come look at it here in just a second. Okay, my suggestion for this is let's just make it an easy problem. Now, we have to make sure that we put stuff back when we're done. I can rotate both these points, or not rotate, I'm sorry, I can translate both of them 2 to the left and 1 up. So it's now essentially like I'm at the origin again. Now, if we move it and then rotate it, what do you think we have to do at the very end? Let's put it back where it's at. So check it out. I'm going to simply do this first, and I'll help us with the first point. We have A winds up at A prime, and we're going to get to like a quadruple prime here, and it's going to be ugly, but that's okay. What does this A prime become? -5, 5, and B prime? 4, 16. At this point, I have moved everything, which means we're now rotating essentially about what? I didn't even look. I just trusted whatever I heard. Yeah, we're now rotating about 0, 0, and we're rotating 90 degrees about 0, 0. Is there a rule for this? Rotate it and move it back. Cool. I'll give you guys another minute. Coming back together with these. If people got the wrong answers, I can see exactly where it happened. We are adding compositions here to make the problem easier. Now, you could do it just as well, not as fast, but just as well if you had a big graph paper and tracing paper, you could find all these points. You could do the same thing. However, in this one, I'm just going to change color each time. And let's see. Now we're going to do what? We moved it. Everything's at the origin. So a rotation by 90 degrees. Now, I know that when we rotate 90 degrees, we swap places, and then one of the signs changes, right? Which sign changes? Okay, so and notice that, like, and this is ugly, right? So they flop, and then the new y value changes. Do we all get 5, 5? Am I backward? -5, -5. I'm sorry. Is it not -5, -5? I think so. Okay, how about this one? B double prime. -15, 4. Okay, if you stopped here, you're not quite done. Because remember, we changed the problem to make it. If this is originally the point, we moved everything like this. And then we rotated. I now better move everything back because we only moved it to be convenient. Which means we've done our rotation, but now I need to move back to the correct location. There's one more little transformation happening here. One more vector to put me back in the right spot. I need to move 2 back to the right to undo this and move down 1. It is our new vector 2, -1. And we wind up at a triple prime. And I didn't see the mistake when we looked there. I'm sorry I didn't catch it. Because you guys had 5, 5 instead of -5, -5, right? Are you sure? It's supposed to be -5, -5. Sorry I didn't catch that. Look at your rule. What happens with AB? XY maps to X, comma, -y, right? These flop or flip, and then you change the sign on the front one. Okay. Regardless, I think we end at -3, -6. And B triple prime at the very end, we end where? -13, 5. Okay, this weekend. I've done really well about this all day. I'm not giving any homework over the weekend. Cool. I will see you cool cats on Monday.